you might want to care, because I have a first redeem that is still up for grabs right now with channel points. You can even see how many times that you've gotten first. It's like Jet has gotten first a few times, like 4, you know, there you go. I'm still, I need to stop being lazy and make a leaderboard too for that. But it's been a fun little like a competition that we've had around here. But also, hi everyone. Looks like we're up and live on YouTube as well. Excuse me. Shoot, you know, I meant to open up some of the real analysis things just in advance, because I might want to go and revisit some of those prompts. Let's open up that one, and I guess we'll even go back 3 meetings, so I don't remember what all I did and didn't do. Okay, but I'm going to say those on the back burner. We're going to look for questions first. Okay, so we have 2 DMs on Reddit. Let's go check those out. Oh yeah, this poor soul. They had this stats problem just to get a confidence interval for proportions. And this problem used pi to represent the population proportion, and this person thought that it meant pi is in 3.14, which is completely understandable. But it doesn't. It's just, in this case, it's just a letter, same as p. So let's see what they replied back with. Wait, there's no way in heck they did that. If you took the midpoint of, no, maybe they did that later. But a proportion is never gonna be over 1. So maybe they're talking about, wait, what is the formula? Is square root PQ over N. So you have to find the confidence interval. They use 260, so that is what you're supposed to do. Square root 260 over 500 times 1 minus 260 over 500. Over 500. You also get square rooted. Do not think you can escape from that square root 500. There. You can't hide from me. Yeah, so that's not gonna be anywhere close to pi. We could multiply by the z, the critical z. I mean, I don't know. They got their answer. I'm gonna face what's what they actually did. It's either a crazy coincidence or I think they did use pi as their sample proportion, which will be a very understandable mistake. Let me confidence interval z scores 2.58. That's not going to be 3.14. So yeah, I don't know. I don't know what they did, but they said they got their answers. So that's the important part. I'm not going to reply back. There's nothing to say. Why do I have a quote there? That's weird. Well, I still explained why that there's something wrong with the answer, so I'm not sure what else to tell this person. I'm going to move on for both of these. Hmm. Adult algebra? What is adult algebra? Okay, there's an adult who hasn't taken algebra before. Okay, I was wondering if like it'd be like explicit algebra. Like MatPat just released his last video. I haven't heard of them. It seems like the trend on YouTube is to retire now, though. Retirement is all the rage. This one has answers. I was just curious, like, by the phrasing of adult algebra, but they just mean like, that they are an adult who's getting back into algebra, rather than the algebra being about adult topics, which is, I guess, what I was secretly hoping for it to be. They teach kids and adults different algebra. Oh yeah, Harambe, it's been a minute. I mean, yeah, you probably teach it differently depending on the age group, but it's kind of funny. Or it's like I just like the phrasing of it, so I clicked on it. Game theory, Spectre. Got that first. How was skiing, dude? Game Theory is a channel that announced the retirement in January, so the last video will be March 9th. I think it was like Tom Scott who started the trend. I never watched like any of like Tom's videos or any of the people who are like now YouTubers that I watch are retiring, I guess, is how I should phrase that. So the second day was amazing. Wait, you went skiing for 2 days? You were here on Thursday, you said you were leaving tomorrow, which was yesterday, and now you're already back? Are you a time traveler? But glad to hear that the second day at least was amazing. You've been skiing 2 days. Studying a lot at your undergraduate course in your junior year. And you gave your first dynamics lecture this week. That's cool. Your undergraduate course. So are you an undergraduate taking a graduate course based off that phrasing? And you're giving a dynamics lecture? What is this? Oh, you're supposed to express log base 3 of 5 in terms of A and B, I guess. Okay. So I assume we're going to need to change a base formula for the second? Or is that log base 3 of 45? Or is that log base 10 of 45? Or could theoretically be even like ln. You're taking graduate courses. You have a lecture to... Wow, that seems like a... As far as I know, it's a very rare opportunity. Sorry, that alert makes me laugh. Spectre, thank you so much. 11 months. You are the first... Yeah, you subbed on the very first day I was affiliated, I think, which... Thank you so much. That means next month will be on this day. I guess will be my affiliate anniversary. That's pretty cool. Wait, isn't tomorrow your birthday? Or was your birthday a few days ago? Crap, I completely forgot. You and Who both have your birthday like right around today. But Rame, that's awesome that you're able to give lectures. I feel like it's a very rare opportunity for an undergrad. I haven't heard of that. But yeah, Spetry, thank you so much. 26? Oh, never mind. It must have been who is either about to have a birthday or just had it. Or, really, I think guys were within a few days of each other. I guess I'm crazy. I'll see if who pops up then. I'm a little bit scared by the lack of base on the log, because that could mean 10 or it could mean E. Right, you also have a birthday on the 26th of March, you know? To trade secret. Your watch streak is gone again? Oh no. What were you up to? Was it? Oh, because you went skiing, I guess. You probably weren't here yesterday. You were blessed because you asked the professor if you could, and since you took him last semester, you only drew A in the class, he let you. Wow. That's so cool, dude. Like, I think being able to, like, give a lecture like that will be so much fun. And so if I can also, if I ask another question and expose my ignorance here, when you say dynamics, is that like modeling or like what does dynamics actually mean? Because I think of like differential equations and like, I guess like systems. I guess that maybe it could be even be like more like a physicsy thing too. Either if you have the birthday on the same day as you, you know, that would be convenient, Spetry. You have to message to continue the streak? Oh. I feel like I've gotten my streak updated when I've plugged in someone's stream without sending a message. I know Jed has said it's taken him sometimes like hours for it to update though. Like you said, like, oh, you know, 2 hours in, my watch streak finally updated. So maybe it's not that reliable? I'm not sure. Yo, Zach, how's it going? Yeah, no, as of this stream, Jed had a 30-day watch streak, but it's going to be dead today because he's going on a business trip. So there's going to be 2 watch streaks that just died. Engineering dynamics, so like how things move, whether it be translational, rotational, or even both in some cases. Ooh. That's an awesome opportunity, Harambe. Really happy for you. It also looks great if you want to go to grad school, I bet. Got 5,000, must be time for a drawing soon. Oh, I guess so. I guess we need to just play. I don't really see where this problem is going. My only instinct is to do a change of base here with the log base 10 to get it to log base 3. So I guess let's go to the whiteboard and play around with it. Because I feel like for a problem like this, I should just be able to look at it and know what to do. But I really, I'm going to be guessing here, which is okay. But I wish I didn't have to just guess. Okay, so we're calling log base 3 of 6 equal to A. We're calling, I'm going to say it's log base 10 because later on their post they said log base 10 for something, so it's equal to B. And we want to express in terms of A and B what log base 3 of 5 is. So the log base 10 seems like the most immediate issue, so let's do a change of base. Equals log base 3 of 45 over log base 3 of 10. Now what? we could rewrite that as 9 times 5 and use some log identities here. I don't know if that necessarily helps us though. Well, ooh, yes it does. Yes it does. So let's rewrite log base 3 of 45 as log base 3 of 9 times 5 for log base 3 of 10. Ooh, well, it sort of helps, I guess. Since you have multiplication on the inside, we can do an identity to make it the addition of 2 logs. So we do have a log base 3 of 5, which is good. We want it to be only A's and B's though, I think. So log base 3 of 9 is just 2. I don't know if it's good or bad to actually do that though. So I guess log base 10 of 45 is also equal to B, so we could say that B equals all of this. We need to incorporate like the log base 3 of 6 somewhere in here though, right? I might see where. We want to keep this as log base 3 of 9. Maybe. I mean, I might be crazy here, but I'm thinking we could break this. This has a log base 3 of 5 inside it as well. So I'm gonna, I guess, back up a step. In this step, I'll write it as, I'll rewrite 10 as 5 times 2. And then in this step, we'll do the same thing. And so I guess I was hoping that the 2 and the 9 can interact somehow. And we'll get 18, and that's a multiple of 6. It's kind of where I was going with this. But if you have 2 logs divided, that doesn't really mean all that much. You could do an unchange of base formula. But we also have like log base 5 over log base 5, and that's weird. Maybe we can multiply each side by the denominator. Kind of an interesting problem. I'm not very confident in what I'm doing. Oh. So it was just blindly get all the log base 5s grouped together and see what happens to the other side of the equation. I did a couple of steps there in my head, which I hope doesn't screw me over later. So I want to somehow get a log base 3 of 6 in here. I don't know if it's going to be possible, though. Anders, hey! Good to see you, too. Hope that you've been well. Just work on this, like... The problem should be simple, but it's kind of deceptively hard. So you gotta really play around with log identities here. Is there a more direct thing? Like, if you just divided these off the bat to get something nice? I mean, I should be looking for simpler techniques than this, right? Maybe not. I don't know. So like you could technically like bring the b up as an exponent, right? And then you could combine those two logs as 9 over 2 to the power of b. But that, what do you do with that log? Can we do some fancy, like multiply this by 3 over 3 to force the log base 3 of 6 in here? I'm just going to make that, maybe we don't need that to be log base 3 of 9. We'll just write it as 2. Why did I put the closing braces there? We still have a log base 3 of 2 that kind of we're just kind of stuck with, I guess, though. And then log base 3 of 6 is a. This feels pretty close. Oh, wait, I shouldn't say over. Well, we can do log base 3 of 5 over b minus 1. Like, we're nearly there. We just need to... What is log base 3 of 2? If you multiply it by 3 over 3... Oh, is that it? This is so weird. Just too much work. Everything's going well? All right, well, yeah, Anders, please take all the time you need. And RBA over on YouTube, hello, welcome in. How's it going? All right, so if I make some spaghetti, some delicious arrow spaghetti, come over here, say log base 3 of 5 is 2 minus AB minus B log base 3. And then I say 2 is the same thing as 6 over 3 over B minus 1. Then we do the same thing. Wait, am I doing this right? When you have division inside a log, you can do a subtraction. Yeah. Base 3 of 3, which we know what that is. 2, there's so many subtractions. Minus AB minus log base 3 of 6 is A, so AB, plus B, log base 3 of 3 is 1, okay? Over B minus 1, combine the ABs. I guess that's your answer? We could verify that in Wolfram Alpha. Funky problem. You found 2 hard limits that your math teacher gave us as an optional homework for a bonus. You need 2 minutes to how to solve it. Yeah, sure, RBA. If you want, you can type it out in chat, or you can post it in my Discord. Whatever's easier for you. Put them on Discord? Sounds good. While you're doing that, I'm gonna see if we can plug in what I got at the end here. So we have 2 minus 2AB. A is log base 3 of 6. B is log base 10 of 45. Do you have a math question curious as to how I'd solve it? Yeah, sure. I'm gonna look through RBA's thing first, and then I can look at yours if you want, Anders. All right, let's see if this comes out to be the same as log base 3 of 5. This horrible thing. I wonder if we're going to... Oh my god! Log base 3 of 5! Look at that! I actually did something right! And RBA, once you do post it, just like put a little put a message in the YouTube chat so I know to check my Discord. Find 2 consecutive multiples of pi to the negative 26 over 5. That bounds 3 to the pi? What? 2 consecutive multiples of pi to the minus 26 over 5. That bounds 3 to the pi. That's, let me try and type out a response to this person facing technical difficulty. Oh, shoot. With posting it in integer multiple? Okay, yeah, that's what I assumed. You're going to type it here? Okay. Sounds good. RBA. Oh, and so the 2 consecutive multiples that bound it means that the first multiple is below 3 to the pi. This next multiple is above 3 to the pi. Okay, for some reason I was imagining that they both were bounding from above or bounding from below. Okay, yeah. I just got into that in my head. I don't know how I'm going to do that, but at least I understand what the question is. Yo, random dude. How's it going? Yo, Penn Center. Thank you so much. Dan, hey. How's your stream at? I was watching for a bit. Those integrals were pretty cool. Stooky, hey. That bee is so adorable. You want to go for a walk with the dogs? And random off the internet, you got to relive your childhood for a moment. Hopefully it was something fun then. But yeah, I hope everyone is doing good today. Andrew's posted a question in chat that I need to take a look at, and then RBA over on YouTube is typing out a problem. Anything rules tough? Yes, the dialogue one. I never heard of dialogue. Except for like when Wolfram Alpha gives it as an answer and I get terrified. Actually, maybe I shouldn't prioritize this. I was doing this question off Reddit involving expressing log base 3 of 5 in terms of log base 3 of 6 and log base 10 of 45. It's kind of an interesting problem. It wasn't as easy as I thought it'd be, but let's tetration RBA? Oh no. Okay, that's a lot harder of a limit than I thought it'd be. Or is that just an exponent? Okay, so wait, so RBA is that up arrow like tetration, or is it just a normal x plus 1 over x to the power of x? I'm copy pasting over to the Twitch chat in case anyone see. So if it's just to the power, oh, okay, good. That that looks like e to the x. Isn't that the definition of it? Or it's just E, maybe, yeah. Okay, yeah, it's E. Hey, he XD. Yeah, so we just learned about limits, you don't know how to get E. Now, this is something... Oh, X over N, okay. Prove it taking the ln of each side. So this is basically what we have here. Yeah, I feel like I've done this before. I just have to remember. So sometimes you just, I think, depending on your context, you sometimes take this as a fact that you don't prove, or sometimes you can take other things as fact and prove this. I think my theoretical knowledge on this is very poor, but you don't know what E is. Oh, we should start with that then. Because you're gonna have to, if you're doing limits and stuff, you're gonna have to get comfortable with E if you're in like a calculus class. So E is Euler's number, or it's called Euler's number or Euler's constant. Euler's number. So E is an irrational number, just like pi, but where pi has to do things with circles, E has to do things with exponentials, but it kind of shows up in weird places. So just like pi is 3.141592, whatever, E is 2.71828, whatever, it has no pattern. We're gonna do it off the internet. Yeah, there were these random chickens roaming around and one got close enough to pick up. Threw chickens at people you don't like? Okay. The chickens were peaceful with it, I guess, or yeah, you're playing Zelda in real life. So an exponential, that's a good question too, RB. When I say exponential, I just mean anything involving a number to a power. No. These are not stupid questions. These are very good questions. So when I say exponential, I mean something like oh, that's probably too small to read, isn't it? Like 2 to the x. We call this an exponential when like there's an x in the exponent and 2 is our base. And so you can also have e to the x in blue here. It just looks the exact same as a normal exponential curve, and which feel like that too, yeah. So yeah, it's always hard to describe like what E is, because on one hand it shows up in many different situations. On the other hand, mathematicians kind of shoehorn it into places because we just like the number E. So just know it's an irrational number just like pi, and it's usually raised to a power of x or something like that. It doesn't have to be. It's just that's often when you see it. It's just an interesting number for mathematicians, I guess. So it can be defined in many different ways. This way is with a limit is one way to define E. Hey, medcode. Oh, you know, I should say, it's pronounced Euler, E-U-L-E-R. It's a name of the person, or as far as I know, it's pronounced Euler. But you, I don't think people make fun of you say Euler, but as far as I know, it's pronounced Euler. You gave like a rule. Yeah, it's honestly it's one to just have memorized. You can show. Penson was saying this way that we can show it, and I can show that on the board too. Make something to the 2I pi equal to 1. Fair enough. That'll probably work as a definition. I guess I don't know about to say like yes or no though. So let me so yeah, I'd say a rule is a good way to think of it. RBA. It just, depending on how theoretical you want to get, you can take it literally just as an arbitrary rule that happens to work out and give nice properties, or you can take other things as rules and show that that's true. So we can do a little exercise here to work with this limit. This work is for a different problem, just kind of ignore it. So if you have the limit as x goes to infinity of 1 plus 1 over x to the x, I think it's what you typed. Let me go back and chat and make sure of that. Yes. So it's a bit of a trick because, or it is possible to evaluate this limit, but it's with using a trick that isn't a very rigorous way of doing a limit. But if you know the limit converges to something, you can name that something as L, and then you can do things on both sides of the equation. The thing is, you're implicitly assuming that the limit converges and it doesn't diverge, as in going up to infinity. But for this one, we're going to be okay. The trick works. It just doesn't work in every situation. So you can show that this goes to E if you're willing to do this trick, and you can do some fancy, or not that fancy, you can do some limit properties to figure this out by taking the natural log of each side, which I should tell you what that is too, I guess. So we take the natural log of each side, and I'll tell you what this is in a second. Actually, it's kind of funny. I was just doing a logarithm problem right here, and the natural log shows up here. But the natural log is a logarithm that you hopefully know what a log is, but with a base of e. And that often gets abbreviated to ln as a natural log. And we call it natural log because it just naturally shows up in places. And we also just arbitrarily use it. So log base e is the exact same as ln. And log base e is, it's the same idea as log base 10. It's just like any other logarithm. Let me just check on chat. Just the value and to show work. To find the limit, show it converges. Yeah, so this is probably what I would do in your situation, RBA then. Doing this ln of each side thing. Now there's a limit property that says we're allowed to bring this ln inside of the limit without changing its value. So let's do that. I'm gonna have to erase some of my work here. That's okay though. All right, and so now we did this because we want to use logarithm identities here. When you have a logarithm with something raised to a power, this x here, this power can come out front. That's an identity when you have a logarithm. So you get limit as x goes to infinity, x ln 1 plus 1 over x is equal to ln L. Now how do you evaluate this? Do you need L'Hopitals for this? Or is there a trick that you can do here? I assume you don't know L'Hopitals yet. Let me look back at the reference here. Medcode, you didn't understand the last step? You usually use L'Hopital's pen center? Oh, okay, maybe I'll just do L'Hopital's as well then. So Medcode, let me bring it up. Oops. Bring me back. I accidentally hit a mouse button that is the back button on the browser. So Medcode, I used this identity right here. This one. When you have a power inside of a log, that power can come out front. That's all that happened in that last step. And so RBA, I think for this next step, I'm going to use something called L'Hopital's rule, which I hope you heard of. It's going to be hard to do it without it. I'll type out how it's spelled in chat, so hopefully you've seen this before. If not, it's going to be pretty hard to evaluate this limit. I don't know if there's a way that you can do it without L'Hopital's. So I'm saying we need L'Hopital's here because if you try to plug infinity into this as it is, you get infinity times ln of 1 plus 1 over infinity. 1 over infinity goes to 0, so you get ln of 1. ln of 1 is 0, so you get infinity times 0, and that's an indeterminate form. We don't know what to do with that. So we're allowed to use L'Hopital's, but we have to get it into a form that we can use L'Hopital's in first. So let's... I'm going to rewrite x as 1 over x. So we're not changing the value of anything, but we need it to be a fraction for L'Hopital's to apply here. So we haven't changed a single thing about the value of the function yet, but we do need it to be as like a fraction here, so we can derive the top and then derive the bottom. And now at this point, I'm going to use L'Hopital's. I'm putting the LH over the equal sign just to, you know, kind of say what's happened here. Not everyone does that though. We're in math and French, so it's child play. Oh, cool. Okay. Oh, do you know what to do from here? I'll still show the rest of the problem, but if you already know what to do, please don't feel obligated to like hang out if that's all you need help with. Or if you just meant the pronunciation of L'Hopital or Euler or whatever. Was Euler French? I don't know. Anyway, I'll just proceed to the problem, but if you already understand the rest of it, then no worries. So when we apply L'Hopital's rule, we derive the top on its own. So ln derives to 1 over whatever's on the inside. And then chain rule, we have to multiply the derivative of the inside. 1 derives to 0, 1 over x derives to minus 1 over x squared over, now derive the bottom on its own, 1 over x derives to minus 1 over x squared again. All right, so now let's kind of unflip these fractions and see where the dust settles. So actually, we have a minus 1 over x squared and a minus 1 over x squared on the top and bottom. Those can just cancel. So we just get 1 over 1 plus 1 over x. And I think at this point, we're ready to plug in infinity. So let's remember that's equal to ln of L still. Okay, so if we plug infinity into here now, 1 over x, well, yeah, for infinity, 1 over x goes to 0. But so it's like 1 over 1 plus 0, which is just 1. So we'd say 1 is equal to ln L. And now L is our limit, and we want to solve for L here. So now let's take e to the power of each side. Because, I should write a little side note. Actually, I'll say like, you know, e to the power, and e to the ln of L. The e and the ln, they basically cancel out. It's another log identity. And you're just left with the L. So the result that you get is e to the 1 or just e. So that's how I'd say that you would do that kind of limit. It does use kind of like a dirty trick, I guess. It's not really that like dirty, but setting limit equal to L is nice for algebraic manipulations, but it's not the most like rigorous theoretical thing that you can do with it. But it's kind of the easy way. You get the French? Oh, okay. No worries. So let me know if you have any questions on that RBA. I wasn't going too fast there with all the identities and stuff. In medcode, no problem. Thanks for being here. It's good to see you again. Everything fine with those things? Okay. All right, it was RBA who asked the question, so I guess RBA, let me know if there's anything from you, and if not, I'll move on. Because Andrew still asked that question that we should at least try to do. I don't know if I'll be able to do it, but Topuria Winnen? Limit when x tends to 0 from the right of ln of cosine 6x over ln of cosine of 3x. You got negative form of the test. That, and you got 10 out of 12 total score. The test not the limit. Oh, okay. So, oh, you don't know if you got that one right or wrong? Because you missed that question? Oh, okay. I'm not sure exactly how we're going to do that. Let me finish up the problem I was talking to RBA about, and then I'll take a look at that. You get it all became people when we talked about L'Hopital's rule? Okay, so are you new to it? Because that's... Let me, it'll be easier to maybe look up a resource on it. Sure yourself as much similar than it seems at first? Okay. L'Hopital's... Not multivariable. So, yeah, exactly that. What he at XT said. For certain limits, if they result in a certain thing, like infinity over infinity, or 0 times infinity, you're allowed to use something called L'Hopital's rule, and you just derive the top and derive the bottom, and the limit is still the same. So, yeah, that's all that happened there. If you want this really useful, hey, glad to hear it. You and I are in the same class. Oh, nice. No, those are not stupid questions at all. Thanks for letting me know that you guys are in the same class. This site in general I love for everything calculus, so this is the page on L'Hopital's rule, but just like look around through here, and there's so many helpful things for everything calculus. Yeah, if you have more questions, please feel free to ask. Let me sorry, Andrew, I feel bad that I keep skipping over yours, but since these are like homework questions, I like want to try to answer them. So Topuria is saying limit as x tends to 0 from the right of ln of cosine of 6x over ln of cosine of 3x. So yeah, if you just plug 0 into that directly, you get ln of 1 over ln of 1, which is 0 over 0. So yeah, this looks like a L'Hopital's to me 2-pin. Let's try it, I guess. See where it goes. I'm just gonna erase this. Who cares? I need space on the whiteboard. Okay. So we have the limit as x goes to 0 from the right of ln cosine. Let me get the like people are okay with it. You just want to know what a derivative is. Please have to answer the question. Yeah, sure, RBA. What the heck am I doing? Okay. So ensure we get the question copied down, right? You got -4 for your answer. You don't know what the right answer is. We can Wolfram Alpha in the worst case scenario. Okay, so first off, if we try to plug 0 in directly, we'll get ln1 over ln1 equals 0 over 0. Does not compute. That's an indeterminate form, so we actually have to use Wappler's rule. It's kind of funny. Like, I feel like when I get people in chat asking questions, they tend to be about similar things, even though they're completely different people. Like one day I had like multiple different people asking about Fourier series. Today it might be a L'Hopital's day. So yeah, let's apply L'Hopital's rule to here too. Oh shit. Woo! Almost died there. No, and that's not an exaggeration. Okay. Okay, so we derive the top on its own. Ln, when you derive ln, it's 1 over whatever's in the inside. 1 over, oh my god, my whiteboard is still wobbling. Times chain rule, derivative of the inside. Cosine derives to negative sign. Chain rule again on the 6x multiplied by 6. Same procedure here for cosine of 3x, but we'll just end up with a 3x, or with a 3. 1 over cosine 3x. What? Oh, you're just memeing, Anders. Okay. No. Sine 3x times 3. Like that? Okay. So let's look for, I guess let's clean up the fractions here and see what happens when the dust settles. We've just gotten rid of the logarithms. Okay, so we have sine 6x on top, well, minus sign. We have a minus sign and minus sign, those cancel. We have a sine 6x, we have a 6. 1 over cosine 3x on the bottom can come up top. Over. On the bottom we have cosine 6x, we have 3, we have sine 3x. 3 sine 3x cosine 6x. That's what, okay, so that's the cleaned out version. We can get some tangents here. I don't know if that's helpful. Don't die, Don. I'll try not to. The stream cut out? Oh, I did hear the alert. It played on my end. If it didn't play on your guys' end, you heard it too, Pen? Okay, that's good. I'm not sure what's up then, but hopefully it's not a problem with the stream. So we can say sine over cosine of 6x is tangent 6x. That's where my head is going with this. 3 over 6 cancels to 2. Tangent 6x. Cotangent 6x? 3x? I don't like that. Oh, wait. Do we need a half angle or double angle? Same thing? Maybe we don't want to do it like this. Maybe we want to double angle that sine. Yeah. Okay, no, let's not go to tangents. Okay, so on that sine, I'm going to use the identity sine 2x equals 2 sine x cosine x. So when we have a 6x, that's going to be 3x and 3x. then that cosine 3x stays the same. Three sine 3x. Now for that cosine of 6x, we have options for the double angle. I don't know which one we want. Three x over 6x. Don't worry about the cosine. Okay. Trust your pen. We do get a cancellation here with sine 3x, sine 3x. We get a cosine squared 3x over here. Oh, you could double that one with a cosine squared. Is that maybe where this is headed? So, okay, sine 3x, I'll cancel those two. And then I'll put cosine times cosine as cosine squared. They tend to 1. Oh, can we just plug in here? What are you typing? Is that Enigma? What are you typing? Or someone just happens to have Enigma's name in the YouTube chat? Could you not, like, spam if you don't mind? I don't think that's actually Enigma. Okay, you're getting muted, dude. Give me 1 minute. Okay. There's typing the entire alphabet in the YouTube chat. We can't have that. We only want numbers here. When I see RBA and he going back and forth. For the second IHOP? Dude, I'd love to go to IHOP. What happened to the 6? What 6? Oh, that 6 canceled with the 3. Oh wait, why did I put the 3 back? The 3 shouldn't be back. There we go. Thank you, Stookie. So wait, does this go to... Oh, you're right. Yeah, I was getting too fancy. Now if we just plug in 0... Yeah, over here the signs were a problem because that's 0 over 0. But now the signs we've gotten rid of them. So now we're able to plug in 0. Okay, that's a great catch. Cosine of 0 is just 1. So we just get 4. So it's positive 4, not negative 4, I guess. We can check that in Wolfram. Hey, Richard. You guys both get saves. Oh, yeah, that's restricted to mods, isn't it? And if anyone else... Did anyone else? Jeff was helping too. That's the right answer? Okay, hell yeah. So who's asking? It was, Oh, Sinome. Sorry I missed your message, Sinome. Died at the hospital? Dude, exactly. Okay, so to Puria. That's the question. Just for fun, we'll still plug it into Wolfram. And then Bio, I do see you. I've been keeping Anders waiting. You missed the entire point of the question because of the sign? It seems like it. Yeah, I'd be pretty salty about it too. I'm sorry about that. Kind of crazy that that's 4, but yeah, looks like it. Do you have time? All right, Anders, thanks for being understanding. Okay, so Bio... You need the Gamma badge to hear it? Maybe. Sorry, I'm scrolling up in my chat right now. Oh wait, shoot, and RBA was asking about what a derivative means. But EXT was kind of helping out with that. Yeah, so basically my explanation of what EXT would say that a derivative, the most important like one sentence explanation for a derivative is that derivative is the rate of change. A function. That's the shortest accurate summary that I can say of it. Do you have any tips for calculus or just like limits? For me, just do a bunch of problems and eventually you see the patterns. Unfortunately, you just have to be okay with struggling at first and keep trying with it, and eventually it'll sink in. That's how I learned calculus, at least. Okay, so bio. You have the ratio between seventh member from beginning and seventh member from the end. The third root of 3 plus 1 over the third root of 3 equals 1 over 6. What's the sum of the binomial? Oh my gosh. Are we even able to calculate? Okay, I have a different question from the Twitch chat med code, and then I can look at your limit. Gosh, these are such weird questions you have to do, bio. The seventh from the beginning and the seventh member from the end of the third. I assume that's to the end. Oh wait, what's the actual ratio though, bio? I don't think you typed that. Unless I missed it. Oh yeah, if you want to put the question in there now, I'll get to it when I have the time. You can put it in the Discord too if that's easier. And I'm waiting for more information from bio. So if you post it first, I might just try and do yours, depending on how involved it's going to be. In the meantime, I'm going to erase my whiteboard. Okay. And then to 10 probably. Okay, so I remember you helping with that question. This is a different one though. I think that one had square roots with a 9 to 10 one, which you definitely helped out a lot with. I remember that. All right, looks like Medcode posted their question before bio sent the rest of it. So let's look at Medcodes. Sigma and Pigma? I never heard of Pigma. Isn't that a villain in the Star Fox series? Pigma? And it was like literally a pig? Oh, the product. Oh, I get it. My mind went to a very different place there. That's a good question too, because summations are kind of yeah, I know what you're talking about now. So oh, and we have a product here too. Really? Limit as x goes to infinity of 1 minus cosine of kx, the product of that from k equals 1 to k equals n over x squared? Huh. Pick my balls. No, don't pick my balls. What the heck is this? How do you do this limit? Oh, wait, yeah, so yeah, if you didn't hear, we need to know what the actual ratio is, I think. I don't think you put that in the question. Oh, no, so I know what it's asking. I just don't know how you do this, I think. So cosine of kx, so we don't have a limit of cosine as it goes to infinity. Your teacher gave you starting? Oh, please put that, yeah. I'm assuming it's cosine. Tailoring? Oh, it could be Taylor. Let's see what medcode puts for like what the hint their teacher gave them. Top is bounded and therefore goes to 0. That could be it. A flash of genius. So if the top goes to 0, we're gonna get 0. Like, are we gonna have to L'Hopital's this? Like, that's an ugly thing to derive. Need the 1x and x squared terms of the infinite product. But how do you get the Taylor series of the infinite thing? The limit tends to 0, not infinity. Oh, okay, as x goes to 0. There's no odd x terms because it's cosine. Do it for each cosine and multiply them together? Huh. All right. So Medcode, do you know what a Taylor series is, I guess? Like, have you seen that cosine of x is equal to this? Like, infinite sum? You ever seen that before? Okay. So what hint did your teacher give you then? Or like, what did your teacher give you to start it? What, 1 minute? Okay, no worries. Send it in Discord. Sounds good. All right, the problem up on the board while we wait. So it's limit as x goes to 0 rather than infinity. Or correction there. So actually, this is L'Hopital's though. When it's x goes to 0, you but then what? How do you derive that product? Never. I mean, okay, technically it's L'Hopital's. That's not a pretty L'Hopital's. But 1 minus cosine x over x is an identity. It might be that. Oh, wait, what the heck? Is this the result of a Taylor series? Let me bring this up on the stream. It was like maybe what Suki was saying with the cancellation that we get. Right, that was like the end result. Huh. That was as m goes to infinity. Oh, okay, no worries. Oh shoot, I brought it up on stream, but I didn't actually show it. Uh, so I'm thinking 1 minus the limit as x goes to 0 of 1 minus cosine x over x. That's an identity. I think it's 1, isn't it? Like, we're just doing that in real analysis. Maybe I'll have to read the problems first next time. Limit of 1 minus cosine x over x. Like, that's just like the limit of sine x over x, I believe. And you get 1. Or, you know, that's like the analogous limit for cosine. No, you get 0. Really? Yeah, this is a difficult one, Medcode. I'm trying to... see what the pattern is here, though. He told us to prove it with... recurrence. Recurrence? It's a French name. Yeah, recurrence is a thing in math. It's something I would think to use here, though. Or I guess it's like, I don't know how we would use it. Taylor is the easiest approach, SPQ. It feels kind of Taylor-ish. Induction? We have to claim that's equal to something, though. I don't know how... they might be talking about induction, yeah. Manipulate the top to make it the usual limit. That'd be nice. I don't know how we do that, though. Like, you could break out a cosine x and a cosine 2x and try to use some identity with those two? Or you take values of m and then you do induction. Like, you do a base case with, like, m equals 1. Look at a few example values for m equals 2 and 3 and see if you can find a pattern. That's still kind of hard. Using L'Hopital is awful. It's being a bunch of sin x over... Really? Doing this, like, arbitrary derivative is kind of scary to me. Okay, so yeah, that's induction RBA. Okay. Induction with this. It doesn't... No worries at all, RBA. I'm happy to try and work through any like language barriers. Oh wait, is it logically valid to use L'Hospitals here? I feel like it wouldn't be. So we'd have to do that induction thing or some kind of weird technique. This is a crazy problem. So we could try doing a few example values for m, I guess, and seeing what it becomes. So that seems like to be what you guys are saying. I really don't know where this is gonna go, but like if we take m equals 1 as x goes to 0. So if m equals 1, we just get 1 minus cosine x over x squared. Now that's not the same as the normal identity because it's x squared on the bottom. So let's multiply by 1 plus cosine x over 1 plus cosine x and see what happens. I assume the limit might still be 0, but I don't actually know that. Is this better or worse? I feel like it's worse. I don't know. So that's sine squared on top. And so now you have two limits of sine x over sine x and one limit of 1 over 1 plus cosine x. So that's 1, that's 1, that's 1/2. So for m equals 1, we get 1/2 for the limit. So I guess we have to try with m equals 2. Thanks for lurking, Pen. Hey, Obi, it's Don who does math. Yeah, you could use L'Hopital, but you have to differentiate a product. Really, Jeff? Because I thought like you run into some issue with like circular logic. Like the same reason you can't do sine x over x with L'Hopitals. I think we have to manipulate the top to make it like the usual limit cosine x over x squared times sigma k squared. Oh, yeah, RBA. Because yeah, that 1/2 coefficient. Because like this 1/2 is the same 1/2 that's in the answer. So we just need to figure out where that sigma k squared comes from, right? Which I don't know where that's going to come from. So should we just try it with m equals 2 and see if we find a pattern? Because I definitely don't see how you do it for an arbitrary m. Oh wait, actually, if we're given that, can we just skip straight to the induction? So wait, let me ask you guys a question. Were you guys given this right-hand side here? Because if we have this proposed thing for the limit, we could skip straight to the induction step, I guess. We just did the base case, actually. Because yeah, if this is like a part of the problem, we could try and show it, like we can assume it for m and now prove it for m plus 1. But if you guys were only given this and nothing else, then it's a bit trickier. But if this is the actual problem, like, we can do this, I think. Probably. Maybe, I don't know. We proved the second. I think we can mathematically do it in its general form. Okay. Yeah, so we just showed the base case for m equals 1, I guess. We could assume it's true for m. So we can assume it's true for an arbitrary m now and prove it for m plus 1. Because we just did the base case for m equals 1. We got 1/2, and that's what we expect from this. So I don't know where this came from, but if we're allowed to just take this as true, or, you know, we're allowed to just use this. I don't know, like, I have no idea where that came from. But if we can just use it, we can do some induction here, probably. You don't see an issue with Laplace for sin x over x? Wait, SPQ, are you trolling? That's like a well-known thing. You notice you also have best beat on Twitch? Yeah, Bob has it. SPQ, it's because when you prove when you prove the limit of sin x using limits, you have to evaluate sin x over x as x goes to 0. And that's before you prove that sine derives to cosine. So that's why you're not allowed to use L'Hopital's. So L'Hopital's gives you the right answer, and it technically fulfills the conditions, but you don't know the derivative of sine until you evaluate sin x over x. M equals 1, m equals 2, m equals 3. He gives a conclusion to prove the other one. I guess we can try it for m equals 2 and m equals 3. You haven't proved it until you do sin x over x, though, SVQ. It's circular logic if you use L'Hopital's to do sin x over x. So we can try it for m equals 2 then as well. Well, let's not bother with the product. So this is where it gets a little bit harder. I assume we want a double angle formula. Is there anything else that we can do that wouldn't be as annoying? Not that I see. I need to remember what that double angle formula is. if there's multiple ways to find it, then maybe there is some other way that you can do it, but I'm just going off what I've been taught. And Nent Mitch Giannis, am I saying that right? So only really applies to your previous sign, prime x equals cosine. I'm not the expert on this, I don't know. I'm just telling what other people have taught me. Blindly. Okay, so cosine of 2 theta, we have options in life. We can say cosine of 2 theta is cosine squared minus sine squared. That I'm not very hyped on. 2 cosine squared minus 1, I think it's going to be our best bet. Or 1 minus 2 sine squared, which I'm not too hype on. So let's try 2 cosine squared minus 1. That's going to be a cubic though, like this looks a little ugly. Like, what do you do with that? Oh, you break it up into 2 different fractions? No, no, no. Yes? No. Like, you have a cosine cubed and an x cubed. Maybe you do want the one with sine. No, that's still messy. Well, this is such a weird limit. I definitely don't know how you do it for m equals 3. I'm already stuck on m equals 2. Could you L'Hopital's this? That feels like... Maybe it's the L'Hopital's. I don't know. You proven this? Let me... Oh, wow, EXT. Okay, thank you so much if you figured it out, because I'm definitely... This is a tricky problem. Yeah, so I'm going to wait for he's posting, so I'm not sure where to go with mine. Squared on the bottom still? Oh, I made it into a cubed. Thank you, Obi. Either way, it okay, why can't you use L'Hopital's with sine x over x? Stack exchange is always right. It's the correct application of L'Hopital's rule. Easy to prove the derivative of sine x and cosine x is possibly circular logic, depending on your definition of sine x. Okay, so maybe there is some world where it's okay. And at least in the way that it's conventionally taught, it's not okay. But maybe there's some other type of math somewhere out there, some other definition of sine that makes it okay. But it's because the usual explanation that I've always heard is that when you want to prove what the derivative of sine x is, you plug it into your normal limit definition, you do the addition identity, and you end up having to evaluate limit as h goes to 0 of sine of h over h. before you've proven that sine of x derives to cosine. Oh, and actually, yeah, hey, same with this limit here. Actually, but that's for cosine though, so maybe that's not circular logic. We'd have to look at the derivative of cosine, I guess, to see if there's a potential issue there. Tautology? I guess so, yeah. Take a couple minutes though? Okay. Thank you so much for working on that, hee hee. You define cosine x as sine prime of x. Oh, I guess you could define it like that. Okay, so Bio, I don't think we ever heard what the ratio of those two terms was in your question. And then we still have the problem from Anders. And I don't think I'm missing anyone else. I hope I'm not. So I guess we'll at least get Anders' problem written down here. I'm gonna have to scroll up a bit. Actually, /user Anders. Let me just look at the chat history. No user match. Oh, come on. Okay, click on Anders' name. Go to chat history. There we go. So oh, okay, you copied it. Thank you. You don't see why wouldn't be logically valid. Oh, I mean, I'm not the person who can tell you that, SBQ. I repeat things that I've been told. That's my level of knowledge in math. So Anders, you want two consecutive integer multiples of pi to the power of minus 26 over 5 that bound above and below 3 to the power of pi. Oh, shoot. And coconut crab. Okay, look. Antiderivative. Oh, gosh, coconut crab. That's going to be a partial fractions. You see a L'Hopital proof, you don't really see the induction plan. I don't know. I was just going with it. I don't see anything with this one. So like integrating metcode is what that means. Okay, so let me look at Anders' question first, and then I'll try yours, coconut crab. But I think coconut crab, that's gonna be a pretty long problem. Integrating 1 over x cubed plus 1. Okay. Curious about what your first approach would be? I'm not sure what my first approach is. Reciprocal or rational? Coconut crab, reciprocal or rational? I'm not sure what you mean by that. It's both, I guess. Like you call it a rational function. And it is a reciprocal of x cubed plus 1. But to actually integrate 1 over x cubed plus 1, it's going to be a pretty long problem, which I can do. I just want to get to other people's questions who have been waiting. Okay, so what would my first approach be here? We have to basically solve this for k. So we could try and ballpark. That's like I guess my first thing is to try and get very loose estimates for what each of these numbers are, so we have a sense of what k should be more or less. So like 3 to the pi, we can say it's about 3 to the 3, which is 27. And pi to the minus 26 over 5. It's about 3 to the minus 26 over 5, which who knows what that is. um, 1 over, I mean, maybe we'll do more approximations. So like that's about 26 over 5 is 5 1/5. Like 3 to the 5th, I guess. Well, I'm doing some real hand wavy things. I'm estimating estimations. I feel like that's bad, but 3 to the 5th is 81 times 3, which is going to be 243. Well, I mean, really, you just want, so you expect k to be something like 3 to the 6th then? It's about 5.2, just in case. Oh yeah, I could have done as 5.2 as well. Well, I mean, I would have still chopped off the 0.2, but so we expect a k to be, what do we expect k to be? I guess 3 to the 8th, around there? Just so we get 3 to the 3 when we get that division. So, I mean, that's just kind of get general stuff. Like, this isn't like the how to actually do the problem, but just to get something that seems reasonable, or just to get a sense of what would be a reasonable answer. I'm still not sure how we actually are going to do this problem. Like, if I just take one side of the inequality and divide each side by that pi, like what happens here? That sure is a number. Simple mental math here, I'm sure, for everyone who's watching. Do we get anything interesting if we, like, maybe it's, you have to do some kind of like, we're going to treat something as a variable. Like, I'm thinking of it like a system of equations, I guess. I don't know if that's right. System of inequalities, I guess, where like 3 pi and that are variables. I don't know if that's the right idea, but maybe maybe I'm doing it the wrong way. Like I'm trying to get an exact solution when these are inequalities. Use the calculator for those ugly numbers. Really? Well, doesn't that just make it very easy if we can use a calculator? Like, could we name the next integer that's above 3 to the pi? Like, because I'm thinking like if like the inequality is still true if we say like if 3 to the pi, we're saying it's about 27. So we could probably safely say that like, well, we don't need the next integer necessarily. Like we could say 30 is definitely more than 3 to the pi. And pi to the minus 26, 1 is more than that. Well, that's not... K is less than 30 though. It's nowhere close to 3 to the 8. I don't know. This is weird. One is too bad of an estimate, I think. That's why I'm getting too low of a number. So if we... This is an underestimate or an overestimate for pi to the minus 26 over 5. I'm getting confused with the flipping. So I made that 26 into a 25 to get 25 over 5. So it's a lower power, but it's a negative power. So we made it 1 over a smaller number, which means we've made the entire number bigger. So this is an overestimate. And if we want to have, that means we want to underestimate it in this situation. I don't know if I'm on board with this, but like, no. Just put a 3 to the 5th here, not think too hard. I'm pretty sure this is true that I've written. I don't know if this really helps though. On Discord, you'll send limits, not homework or anything, just something you find while researching on limits. Okay. I'll take a look at it after this, I guess. So, I mean, maybe estimation like this is, like, you need to be maybe a bit more exact than I'm being, because these are pretty tight bounds. Like, the difference between this and this is pi to the minus 26 over 5, and that's a pretty small number. So, like, these eyeballing estimates might not be a good idea. We could sub this into there. I don't know if that gives you anything interesting. I don't know if that gives you anything helpful. But if all of this is greater than 3 to the pi, then you could sub it in there without affecting your inequality. That's what I was thinking at first, like if I treat it as a system of equations. That's not. Wait. I don't think this is helpful. Never mind. K is less than K plus 1? Jeez, thanks. Okay, maybe that's not the right idea then either. I don't know, Anders. You want to treat algebraic instead of numerically as a clever trick? Yeah, I'd be interested to hear it, because I assume that, like, if you do it numerically, isn't it just like 2 steps? Which I guess we can do that. Just so we've at least done some part of the problem here. So you would do 3 to the... But please, like, put in the algebraic way, because I'm not smart enough to figure it out, I think. 12, so... Yo, Jackson, I'm good. How about you? So k is less than this. So we take k equal to 12,136? Like, that's why I was thinking this would be too easy. 12,136. So is 12,136 times pi to the minus 26 over 5 less than 3 to the pi less than 12137 times pi to the minus 26 over 5. Does Wolfram say this is true? True. Okay, yeah. See, if you always do it numerically, it's pretty quick, I guess. But I was trying to do it algebraically because I thought that was the more interesting like problem, I guess. That k equals 4, 3 to the pi over... Oh, yeah, so that's what I just did. But, like, how do you actually... I thought we'd get something that was, like, cleaner, I guess. Maybe that was a mistake. So out of curiosity, what is 3 to the 5th? My, like, eyeballing estimate. Wait, no, I said that was 243. What's 3 to the... Never mind. So my, like, about right answer... Well, actually, no. I was thinking my about right would be 3 to the 8th. 6, 5... Oh, no, that's not close. I knew it needs to be, like, 3 to the 9th or something. I'm not at either, Jackson. I graduated with a bachelor's, like, 5 or 6 years ago. Can prove it works by applying properties of the floor function. Okay, I mean, when I see a bunch of complicated symbols like that, I thought you'd get some really elegant answer like pi or, you know, something. I'm sure the math works out cleanly. I just thought it'd be like, you know, people like it when complicated things like that boil down to something really simple. So that's what I was kind of expecting, I guess. Oh, it looks like there's been some activity in the Discord that I missed. So, okay, this is what RBA... Let me bring it up. So many tabs. Okay. That's a for fun thing RBA asked about. Let me see what Giannis said. I hope I'm saying that right, by the way. Pretty ugly. Should be a way to do this quicker anyways. 2 times I use that limit x equals to 0, cosine of n x equals 1, so I can ignore one part of the expression to make the left hand simpler. So what do you do now? Sorry, your Twitch froze. You just ballin'? Basically, I'm living off savings, trying to see if the streaming thing could potentially work out, because I think it'd be such a cool job to have. But realistically, I'm going to have to get a job in the semi-near future, which doesn't mean I'm going to stop streaming, but doesn't mean I'll have to like cut back in some way. Really, so I was wondering about factoring out a cosine from this product, but I wrote it off because of the reciprocal that you get over there. Do a +1 -1? Oh, what's happening here? Oh, this is like using the induction assumption. And then you have this limit to evaluate. Okay. So this is like part of a proof by induction, it looks like. You have this limit to deal with. At first glance, it looks like it's gonna, no, it's 0 over 0. Oh, and you can just for fun, you can multiply by the limit as x goes to 0 of cosine of nx because that's 1. Oh my god, that's so funny. And then so that gives you, okay, I never thought to do that with a limit. That's really clever. So we somehow make the claim that the limit as x goes to 0 of 1 minus cosine of nx is, this is L'Hopital's. Okay. Then we L'Hopital's again. Interesting. N squared over 2. Oh, and that completes the summation. Wow, that's crazy. That's really cool, Giannis. Thank you for finding that. I definitely can't think of a better way to do it, so. And it's written up so nicely too, which I really appreciate. That's a pretty fun limit. I just like, if you're not given this, I don't know how you find that on your own, I guess. That's where I kind of got tripped up. Like, if we can just use that, then I don't have any issues with this whatsoever. I guess. But yeah, I don't know how you do it if you don't. So I think that's the point of the problem. That you're given this little fact here. At least I hope so, otherwise it'd be kind of mean. I'm gonna drop the most interesting words of her life in the history of ever. She told me when she went to high school with the Everly brothers, who were really, I never heard of the Everly brothers. That's pretty cool though. Looks like Medcode can help explain it. All right. All right, so who have I been neglecting? Coconut Crab. Do you happen to still be here? I'm sorry that I took so long. You guys remember the antiderivative of 1 over x cubed plus 1, which is not a quick problem. Let me, you are here, okay. So I'm gonna, before anything, I'm gonna put this into Wolfram Alpha to make sure that I'm not thinking about it in the wrong way, that it's not some quick thing. But if you want to integrate 1 over x cubed plus 1, I think you got to do some partial fractions. You got to do some partial fractions. Okay. And you have an irreducible quadratic. Okay. Oh, God. All right, so we're going to need sum of 2 cubes here. Okay, so we're going to need this fact here, where a cubed plus b cubed is a plus b times a squared minus ab plus b squared. And do you know how to do partial fractions? Because we're an American rock duo known for a steel string acoustic guitar playing. Close harmony singing. Hey, Isaac, Donald, Don Everly? Hell yeah. And Phil Everly, the duo combined elements of rock and roll, country, and pop, becoming the pioneers of country rock. First Warner Bros. Hit 1960s Kathy's Clown, which they wrote and composed themselves, sold 8 million copies and became... Wow, okay. Actually, Suki, you also get a save for helping out with that product problem too. All right, Coconut Crab, let's see if we can work this one out. It's gonna be a bit of work, but if it helps you, I'm happy to go through that. Okay. So we want to integrate 1 over x cubed plus 1 dx. So we don't have a nice clean way to just, you've seen partial fractions demonstrated, they are above you right now. Okay, so there isn't a different way to do it other than that, unfortunately, so gonna have to learn it for this one. So if that was like x squared plus 1, that's just arctangent, and I was hoping there's some kind of neat trick like that we could use here, but with x cubed plus 1, you have to just factor it into partial fractions. So we can see what that looks like. So let's start by factoring it. The sum of two cubes is x plus 1 times x squared minus x plus 1, applying our formula, right? X plus 1, x squared minus 1 times x plus 1 squared. Okay. So that's a binomial? That's the right term, and that's a quadratic. We can't factor this anymore, unfortunately. It'd make the problem a lot easier if we could, but we just can't. So we have x plus 1, and we have an irreducible quadratic. We have to do partial fractions with these two. So the idea of partial fractions is that, forgetting about the integral entirely for now, so we don't know how to integrate this, we want to integrate this. So the trick we're using is that we know this fraction, it should at some point have come from the addition of two other fractions where you get a common denominator. So it's like we're undoing getting a common denominator here. And so we need to figure out what the fraction used to look like before we added the two things together. So we know that one of the factors here, x plus 1, should be one of our old denominators, and the other denominator should be that irreducible quadratic. And because there's an irreducible quadratic on bottom, we say the numerator is bx plus c. This is kind of just the format that you use for partial fractions. You say it's a constant on top, and normally you only use constant, but when we have an irreducible quadratic, you say bx plus c on top, which I can't really explain that, to be honest. I don't have a good explanation for. That's just something that I have memorized. And now you have to solve this for A, B, and C, basically. And we'll be able to plug this into there once we do know what A, B, and C are. So there's different ways that you can approach partial fractions. There's only one way that I ever remember to do it, which isn't the fastest way often, but it always works. You multiply through by all the denominators. So I'm going to multiply through by x plus 1. I'll do it in 2 steps just so you can kind of see how it works. So I'm going to multiply each side of the equation by that first denominator, x plus 1. So over here, we get 1 over x squared minus x plus 1. Over here, the x plus 1 cancels the x plus 1, so we get just a. Then the x plus 1 just kind of hangs out with the other fraction. Okay. Now we have one more denominator to deal with, that x squared minus x plus 1, so let's multiply through by that. Check chat. X squared minus x plus 1 would give the highest power x squared, so you need bx plus c to balance this. Oh, really, Pen? I'll have to think about that more, but thank you for that explanation. Okay, so when we multiply each side of the equation by x squared minus x plus 1, it cancels out with that denominator on the left. A gets multiplied by that, x squared minus x plus 1, plus, now those two cancel, so we get bx plus c times x plus 1. Okay, perfect. It's actually as much work as I thought it'd be, thankfully. So before we think about the trick that we're going to have to do in the pretty soon here, let's just multiply all the stuff out and group it by the power of x. And if you don't see y, just go with it for now, and it'll hopefully make sense at the end. So multiplying the a inside there, we get that. Now we have to FOIL out bx plus c times x plus 1. So we get bx squared plus bx plus cx plus c. Now let's group everything based on their powers of x's, and I'm going to factor things out even. So x squared, we have ax squared, we have bx squared, and that's all. So let's do a plus b times x squared. Now for x's, we have minus ax, we have bx, and we have cx. So let's get those as a factor, x. Now for constants, we have a and we have c, and that's it. So now we have things grouped as best we can get them, and here comes the trick for partial fractions, which is called equating coefficients. You can technically do it anytime you want, like anytime you have a situation like this, but I guess the first time I ever encountered it was in the context of partial fractions. So 1 is technically the same thing as 0x squared plus 0x plus 1, because, you know, we're just adding 0 here. And the only way for like this relationship to be true, for each side of the equation to be equal, is if their coefficients are equal. Because like the x squared is just x squared. We can never change that. We're given x. We don't get to choose x. But we can choose our a, b, and c. So we have to choose an a and b that give us 0. So the x squared coefficient matches the x squared coefficient. So we know a plus b must equal 0. Similarly with the x, we know that negative a plus b plus c must also equal 0. And then finally, the constant a plus c must equal 1. So it's called equating coefficients because you do exactly that. The coefficient of x squared gets equated with the coefficient of x squared. Coefficient of x gets equated with the coefficient of x. And likewise with the constant. Now we have 3 equations and 3 unknowns, so it's possible to solve for a, b, and c. There's a bunch of different ways that you could go about this. What I would do, either way, we have to use all 3 of these equations, I guess. Yeah, okay, so I guess we'll just take the first one. We'll say that a is equal to negative b, and we will plug it into this third one. So if a is equal to negative b, and we see a here, we'd plug in negative b. So we get minus negative b is positive b, plus b plus c equals 0. So we get 2b equals negative, c. Well, I mean, we can even write 2b plus c equals 0. I guess now we need to bring in our third equation. This one's a little bit weird to solve, to be honest. So we know a is negative b, so let's plug that in. Negative b. We know c is minus 2b. So c is minus 2b equals 1. Okay, so we get negative 3b equals 1. So b equals minus 1/3. Weird number. But it's what we get. So a is negative b, so a is positive 1/3. And then I guess we can say a plus c equals 1, and a is 1/3. So 1/3 plus c equals 1, c equals 2/3. Okay. We know a, b, and c, so we have found the partial fraction decomposition of this. So I'll show it off to the side here. A is 1/3, so we plug it in there. 1/3 over x plus 1 plus b is minus 1/3 x plus c is 2/3. All right. Now, if you really cared to, you could verify it by getting a common denominator here and adding them together, and you should get 1 back. That's a huge pain. We just did a whole mess of algebra, so I'm just going to trust my math that I did it right and hope for the best. We can clean this up a little bit, because like the 1/3 on top, it can be a 3 in the denominator. So like we'd say this is 1 over 3x plus 1 plus minus x plus 2 over 3x squared minus x plus 1. So I hope you're with me so far. I've done a bunch of things. I don't see you typing anything in chat, so I'm going to assume that you're with me here. All this work was in the name of getting this end result here so we can continue on with the integral. So we're a little bit closer now to knowing what the actual integral here is. So we know this is equal to this, so let's plug that in. Miguel Zoo, thank you for the follow. Well, it's been 2 hours already? It doesn't even feel like it. Had some good, cool questions today, and time's been flying. Okay. So now we have something that's possible to integrate here. I don't know if it'll be easy to integrate, but it's going to be possible. How do we want to go about doing this? So I guess first off, let's split up into 2 separate integrals, because that first one is a pretty easy integral. It's the quadratic that I'm mentally contending with right now. I think we'd have to complete the square or something. But first off that, it's more or less like, we can even rewrite this a bit. Let's bring the 1/3 outside. That's like the integral of 1 over x, so we're going to get an ln. This, I guess we got to complete the square, which I'm not happy about. Let's bring the 1/3 outside here as well. So I don't see what else we possibly do with this. So x squared minus x. How do you complete the square with that? Is it going to be 1/2? It's minus b over 2a. Who's that? L. Rude, thank you for the follow. To have more clarity, suppose it's c over x squared minus x plus 1, then be forced to take a equals 0, so you don't get... Oh, really, Pen? Okay. Create a sub to remove the x. Which x? All right, let's get the complete square is going to be 1/4. So we do like, this might not be the right idea, I guess. Um, I think you need to complete the square and then do a u sub to get rid of the denominator. U equals x squared minus x plus 1. What is du? Well, it'll be 2x minus 1. So create it in the numerator? Ooh. I guess so. That might be better, yeah, Pen. Okay. I don't want to... we can erase it. Who cares? Can figure that out again if I need it. So yeah, if we do a u sub there, let's do it in red. So if we take u equals x squared minus x plus 1, that means du is 2x minus 1 dx. Well, ooh, wait. How do we get rid of the... Well, ugh. We could factor a negative 1/2 out from the numerator. Right? No. No, that almost lines up. It's just reversed. If the 2 was over here, we'd be in business. Does that... am I missing something, Pen? Oh yeah, no, Pen. Like you've been practicing for stuff like this. You have to do a u sub eventually and complete the square eventually. Trust me, I've done 60 integrals this month. So no, you construct the 2x minus 1 you need now. Or, well, how do I construct it? Oh wait. Like I just... We say that negative x is the same as 2x minus 3x, and that 2 is the same as 3 minus 1, and then we have a 2x minus 1 here? Is that the point? That feels crazy. Or wait, 3 minus 1, yeah. Can you remove the minus 1? It's bugging me. We can... we can factor it out. I just was being careful with, like... Just like sometimes like signs with fractions get kind of weird, so I was thinking like, oh, maybe we should keep that how it is. But we could say it's also that. But yeah, I trust you. I just don't see what it is, so I'm getting stuck. Bio, I've asked. I need to know what the ratio is. I feel like I asked you like 3 times. X minus 2 is equal to x minus 1/2 minus 3 over 2. X minus 1/2 minus 3 over 2. And that is the same form as that? If you factor a 1/2 out? Huh. So then we do get a cancellation, but then the 3 over 2, that becomes its own separate problem? I'm just going to integrate that first one. I meant to did a u sub with u equals x plus 1 on that one, because the real hard problem is this one. No, minus now. Okay, so we're gonna split this fraction up into two, like the minus 3 over 2 becomes its own problem, is how I'm interpreting this. Technically correct? Okay. The ratios, I don't, if you wrote that, then I missed it, I guess. That's my bad if you did write it. I didn't see you write it, though. Now you want to scale up the first two by 2. Okay. Okay, thank you, Pen. Eventually, I got it. Is equal to 1/2 2x minus 1 over x squared minus x plus 1 dx minus a negative is plus 1/3. Actually, the 1/3 and 3 over 2 will cancel. Over 2 x squared minus x plus 1. I regret taking up so much space to do the partial fractions. I wrote a little bit too big. Okay, so now on this, we can apply our u sub. Wow, that's clever, Pen. Thank you for telling me that. Okay, so minus 1/3. This boils down to 1/2. The 2x minus 1 cancels. That's just u. So that's just 1/2 times 1 over u du. This, you do have to complete the square on. Bring the 1/2 out front, and then completing the square, x squared minus x minus, or plus 1/4 minus 1/4 plus 1 dx. Okay. Irreducible quads are a pain. They really are. So the general strategy used for leading terms in the numerator. Okay, that's good to know. I'm gonna have to remember because I got kind of stuck. I don't know. I remember at some point you had to split it up, split the numerator up, but that's a much easier way to split it up than what I was probably gonna do. Okay, so that becomes minus a 6 ln u, which we'll have to unsub the u in the next step, which is not too bad. This, completing the square, 1 over x minus 1/2 squared. Minus 1/4 plus 1 is plus 3/4 dx. Now we got to do a sub on that to get it to be arctan. Okay. We don't have to factor out a 3/4. Do I want to factor out a 3/4? It does make it easier for my stupid brain to deal with, I think. Just checking chat to make sure. Okay. So we have 1/3 ln absolute value x plus 1 minus 1 over 6 ln u was x squared minus x plus 1. U. So what am I doing here? We factor out a 3/4 and we take u equals to x minus 1/2. I'd be doing like 2 subs. I just want to look at the formula for the arctan. Yeah, you have to introduce it into the, yeah, and if we can just use the x squared plus a squared formula, that'd be kind of nice. We still have to do 1 sub, but if we factor the 3/4, we have to do 2 subs, right? How do you integral resulting in arctan? Actually, this will probably tell us, right? Here we go. So yeah, if you have an integral of the form a squared plus u squared, where a is your constant, you get the integral 1 over a arctan u over a. And I'm sure I could show that if I hadn't just done like a difficult integral, but Okay, so first off, to hopefully make it a bit more clear, we'll do a sub u equals x minus 1/2, and then we'll more clearly have, oh god, squeeze it in here. Du equals dx. So then we'll have u squared plus 3/4, and that's a bit more obviously in the u squared plus a squared form for that formula. Du. Okay. That we know how to integrate via the formula. We are almost done. Okay, so that it's 1/a. This is a squared, remember? So you have to take the square root of that. So it's going to be 1/a, which is it's going to be 4/3 square rooted, which is 2/√3. We can rationalize that in the next step. Arctan u over a again. So over 2/√3. Ugh, really squeezing it in. Plus c. If you do all this work and forget the plus c, it's a sad thing. Really squeezing it in now. Okay, so the 2's cancel. √3 is the same as √3/3. Arctan. Unsub the u. The √3 can come up to the top. √3/2 plus c. So we can maybe mess around with that inside of the arctan, but I think that's just the answer. I hope. Oh gosh. See, so that's why I say that they're a lot of work. Let's check it against Wolfram. I'll get to it like in just 1 second now, bio, since I just got to the end of this integral. I don't know if I can do it, but I'll at least try it. Okay, this matches with my second term. 1/6, that becomes 1/3 x plus 1, right? 2√3. 2√3. It's √3/3. Oh wait, yes, I did. That's also √3/3. And we'll play the 1/6 in. Arctan 2x minus 1. Oh no, did I flip something at the very end? I did. Give a nice one after bio, only if you want to do it though. Is it like just a for fun question or like a homework help question, Elrude? Yeah, I flipped this the wrong way. I wrote too small, I couldn't read my own handwriting. Ah! Goodbye, marker. I'll never see you again. That's A. Oh, I flipped it an extra time. √3/2. √3 on the bottom times 2. So you can multiply the 2 inside there. You could rationalize the denominator if you cared to. Okay. It's another integral, a pretty interesting trick. Okay. Well, if it's like just for a fun question, I guess I reserve the right to just like not do it if it looks too hard, or if there's someone who's like asking me a homework help question. But if there's no asking a homework help question, then I'm happy to look at it. Thank you very much for help with that, Penn Center. Coconut Crab, I haven't seen you write anything in a minute, but let me know if you have any questions on how I did what I did. Sounds good, Elrid. You think you got it? Okay. All right, so bio, let me, I guess, let's look at your question here. Okay, I'm looking at your chat history. You never... Oh, you did write 1.6. I'm so sorry, Bio. I just missed that. All right, so I just copy the problem into Twitch chat. I'll put it into YouTube chat too. 1 over 1 minus sine x dx. Is that a Virstress sub? We were just looking at those the other day. No subs necessary. Oh, do you multiply? I can just try it for myself once I get to it. You probably multiply by like something over something. Like 1 plus sine x probably doesn't do what you want though. Maybe 1 minus sine x and you get something nice. At factors? I'm not sure. I'll try it after I think more about, or after we hopefully do bios. Yeah. Oh yeah, but Bio, I know you're here. I just wanted to copy paste it into chat so people can see the problem. The ratio between 7th member from the beginning and 7th member from the end would have been good if you tried it. It's pretty simple after that. Oh, okay. It probably gives you a nice like sub. Oh, actually no, you said no substitution. I'm not sure then, but we can try that after. No problem, Crab. Thank you for the question. So if the ratio between the 7th member from the beginning and the 7th member from the end for the binomial expansion is 1/6. Okay. 7th member from the beginning. So that's just the 7th term. And then we also need the n minus 7th term of the binomial expansion. All right, let's try it. I think it'll be the same technique that we did last time, just a different situation. Okay. So, you just can't do factorial shit? Tn minus 6 or Tn minus 7? Oh, you might want minus 6, because the nth term is the last one. Oh, nice pen. So actually, wait, let me look at the problem again. If ratio between 7th member from the beginning, 7th member from the end of cube root 3 of 1 over cube root 3. Okay, so, well, thanks to you, I'm starting to memorize the binomial expansion formula. k equals 0 to n, right? It's like that? I should probably Google it. Tell you what the solution is? Yeah, please do, Bio. Oh, dude, I did it right. 2 to the 3 to the 2. Ooh. Wait, is that like, before we get too deep in Bio, is that this, or is it this? Because those are two like different things, like first one or second one. First one? Okay, thank you. So basically 2 to the 9th is going to be our answer. Good to know. The one you wrote is formula for the certain member. Yes, so we want, if we're counting from k equals 0, the 7th member is k equals 6. So that's going to be n choose 6 times cube root 3 to the 6 times 1 over cube root 3 to the n minus 6, right? And then 7th from last member will be k equals, I think you're right, n minus 6, because n itself is included. Because you'd have, okay, I'm just going to count my fingers. N minus 6, n minus 5, n minus 4, n minus 3, n minus 2, n minus 1, n. Okay, yeah, 7. No shame in counting on your fingers. Not fraction. N choose n minus 6 cube root of 3 to the n minus 6, 1 over cube root 3 to the n minus 6. Okay. Hey, Mangoes, thanks for lurking. The other way around? The order doesn't actually matter. We can do it as Elrud said, yeah. We could like write it in the reverse way, but like the first one gets the power of k, the second one gets the power of n minus k. We could switch those around all we want. It's just a name, I think. Because no matter what, you should end up with the same things like here and here, I think, so. Okay, so we're given the ratio. So we know that the 7th from the first, and choose 6 cube root 3 to the 6, 1 over, these problems are so much writing, to the n minus 6 over n choose n minus 6 cube root 3 to the n minus 6, 1 over cube root 3 to the n minus 6 is negative 6. No, positive 6. Is equal, we said 1 over 6? So we agreed to? Yeah, 1 over 6. Okay. Okay, so I prefer setting it up this way because I think last time we did a problem, I set it up like a different way based on the ratio, and I flipped it. This way, I'm pretty sure like it's a little harder to mess up. So let's plug in the formula for choose, which I should look up so I don't mess it up. Combination formula. Okay, n factorial over r factorial, n minus r factorial. I was getting mixed up with permutation. So yeah, let's plug in the factorial formula for choose. So n factorial over r factorial, n minus r factorial. We can simplify these powers a bit too. So 3 to the, or the cube root of 3 is the same as 3 to the 1/3. I'll do it in multiple steps. 3 to the 1/3 to the 6. That's 3 to the minus 1/3 to the n minus 6 over. Now do the factorial formula here. N factorial over n minus 6 factorial. Look at that. Over n minus 6 factorial. We'll do the same power thing we did here. 3 to the 1/3 n minus 6. 3 to the minus 1/3 to the 6 equals 1 over 6. I don't know what these problems even teach you, to be honest, other than doing a bunch of algebra, but we can do it. Okay. So we get a couple, this one doesn't have actually, these all cancel out, all the factorials. So we have an n factorial on top and bottom, which just cancel. We have n minus 6, 1 over n minus 6, and 1 over n minus 6, which also cancel. N minus 6 is just 6 factorial, which we also have there. So I think these all just go away, don't they? So you actually get saved from having to do factorial, any super weird factorial stuff in this problem. So it seems, at least. So now we can do when you have a power to a power like that, you can multiply the exponents. So that's going to be 3 squared. It's going to be, we're going to do 3 to the minus n over 2, or 3. Times 3. I'm breaking this up into 2 separate things based off that subtraction. So negative 1/3 times negative 6 is positive 2. Yeah. Down here we'll do the same thing, except the signs are flipped. N over 3 times 3 to the minus 2. Times that one becomes 3 to the minus 2 as well. 6. Okay. These 3 to negative 2's come up top. You get 3. Their exponents add 3 to the 2 plus 2 plus 2 plus 2 is 8. That one gets flipped down there. Their exponents add 3 to the 2n over 3 to 1 over 6. Okay. N choose k is equal to n choose n minus k. Oh, that makes sense. Thanks for saying that. We can combine these into one exponent. Yeah, I'm not good with combinations, so I don't know tricks like that offhand. I appreciate you saying that. And I guess we need a log here? This isn't gonna... We said the answer is gonna be 2 to the 3 to the 2? I don't know if we're gonna get that. Oh wait, no. We might. Because we want the sum of the coefficients, which... we'll need to get... I just feel like having a log here is so weird, right? I don't know. That, I think, if I did my mental math right. So track the 8 over, multiply through by -3. Divide by 2. Yeah. So I guess we plug that into the formula, like s is equal to 2 to this. I don't... That means n equals 9? Does it? Oh. No, does it? If n equals 9, you get 18 over 3, 3 to the 6. No, n doesn't equal 9. N is that monstrosity. Can you simplify that logarithm in any way? Yeah, you can mess with it. I don't know if it really helps, though. Yeah, log base 316, you can do something with that. Oh, you're right. It is supposed to be n equals 9, I guess. So did I do something wrong here? Well, I must have done something wrong. This should be 9. What did I do wrong? Like, where do we ever get a 2 here? It's kind of what we're missing, I guess. Let me consult my expert named Wolfram Alpha. A few things I want to ask him. Okay, so just see what it is. What is 12 minus 3 over 2? I am sure it's not the answer, but just in case it does find some crazy way to 9, make sure I did actually make a mistake. Yeah, okay, that's not 9. Okay, so what I'm thinking is I want to take one of my steps and plug it into Wolfram and see if it's a true statement. Maybe it's like the first step. I'm gonna cancel out the combinations off the bat, though, I guess. Oops. False. I set it up wrong? Wait, how's that false? You're supposed to solve for n. No solutions exist? Oh. What's the problem then? I just set the problem up wrong. Will there be n plus 1 terms? Ooh. So it'll be n minus 5? Are there? Oh, you're right. Because you start counting from 0. So you have n plus 1 many terms. Oh, that's sneaky, Elrude. So if you have n plus 1 many terms, your 7th from last is n minus 5. All right, good catch. Let's try that. All right. This is all garbage. Not all, nearly all, but we can keep that first line. Frickin' binomial theorem, man. Who even likes it? Get rid of that, get rid of that, get rid of that, get rid of that. Okay, so the 7th from last number is n minus 5 because you start counting from 0 to n. That means you have n plus 1 many things. Okay, so that first line I think is good. It can stay. Now we do have some factorial math that we're going to have to do. n minus 5 is just 5. Okay, is equal to 1 over 6. Try it from here. All right, factorials. N factorial over 6 factorial. N minus 6 factorial. 3 to the 1/3 times 6 is 3 squared. 3 to the negative 1/3 times n minus 6, we said is 3 to the minus n over 6 times 3 to the positive 2. Over n factorial over n minus 5 factorial over n minus 5 factorial times 3 to the n over 3 times 3 to the minus 5 over 3, that's an ugly fraction, times 3 to the minus 5 over 3 equals 1 over 6. Okay, so now we won't get as many things canceling out, and we should hopefully get the right answer now. It was n minus 2? Really? Well, I mean, if you start counting from 0 up to n, like, you have n plus 1 many things. So, like, if n equals 3, you count from 0, 1, 2, 3, that you have 4 things. So, like, the second term is that, but the second to last term, I mean, that's probably not, we probably need more terms to make it more clear, but it's that extra, like, 0 term that we're concerned about, I guess. It's also why we start from k equals 6. Let's see. Okay, you know what? Before we get too in the weeds, let's just see if this gets the right answer then. How about that? Counting from the back. Hey, that boy, Randy. This problem from Bio there in chat. That's basically the question right there. I just pasted again. I think we know the technique, but we're struggling to set it up right. Does 0 even matter then? Yeah, that's a good question, Bio. I guess, I mean, the last one is n? Maybe I'm overthinking that. Maybe it is. I don't know. I don't know. I'm just confused now. But let's see what Wolfram Alpha tells us the right answer is supposed to be, and then reverse engineer it. Dude, how do you do choose in math input? I thought there was a thing like with a big C. Yeah, your math you're doing is not easy. All right, I don't see choose here. Putting the formula? I mean, I guess I'm gonna do that. No, stop. What? Where are you going, cursor? I don't know why you keep adding parentheses when I didn't ask you to, Wolfram, but don't stop it. Oh my freaking! I hate Wolfram's input, dude. I'm just gonna rage at this, I guess. That is clearly not what I wanted, Wolfram. Stupid thing. This is why I don't. This is why I wanted to use choose. N factorial, and I'm just gonna flip everything. 5 factorial. To the 6. Cube root 1/3. To the n minus 6. On the bottom, we have n factorial, which is going to cancel. We have n minus... No, we don't have that. We have n minus 6 factorial. And we have 6 factorial. Cube root of 3 to the n minus 5. Cube root of 3. Oh, cube root 1/3. To the 5. Okay. Please be n equals 9. And, oh my, come on. I believe in you, Wolfram. Do my bidding. N equals 14. Numerical solution, n equals 5. What the hell? What? Oh my, you are doing that to me, Wolfram? You are kidding me. Thank you. Okay. Sorry, I can't help but rage at Wolfram when it does completely insane things that I don't know why I'd ever think that I meant to do that. N over 6. I'm trying to plug in a more simplified version of this and see if I get anything different. Three to the minus 10 over 3 times 3 to the n over 3. Okay. Is that going to be n equals 14 again? Nope. It's, who the heck knows what that is? The analytic continuation of the product log function. Ah, of course. I don't know why I can't set this up. Let's Google it. I don't know why I'm typing out. I have it in my copy paste, but I've already started it. The end of the binomial expansion of CBRT 3 plus 1 over CBRT 3 is 1 over 6. What is the sum of the binomial coefficients? Yeah, I've just learned to know when Wolfram Alpha has something like that, that it's probably, I probably typed something in wrong. Some term from the beginning is k equals 6. Some term from the end, they're saying n minus 6, so maybe the n minus 5 thing was wrong. It's a good thought. Yeah, it's not the exact same problem, but I'm just thinking like that part of this, the problem is the same. Do they also get the binomial coefficients canceling out completely? Their work is so hard to read. Like, what is this too? Is it n minus 6 squared? Let's look at a different one. Okay, so their binomial coefficients do cancel out. Did I just make an algebra error when I did it then? I guess we'll try it again the way that I initially set it up. This is such a weird question. Six, okay. One more time. Those combinations, just can't cancel them off the bat. 3 squared Okay, that comes up top, that goes down below. We can do 4 minus that. Can we rewrite like 1 over 6 as some power of 3? Like, that's like something like this. I don't know if it's a good idea, but so then we can maybe equate the exponents. I think that 2 is going to be an issue though. So if you get a common denominator, that's 12 over 3. Like that, if I'm doing my fraction math right. Yeah, but I mean, the reason we get a log is because of that 2 that's in front. If n equals 9 here, you get 18 minus 24 is 6. 6 over 2 is 3. So you get, or 6 over 3 is negative 2. Because the negative sign in front. So it's 3 to negative 2. But, like, it's wrong. Oh, you wrote it wrong? It's 2 to it's the cube root of 3? I thought they were just doing a different problem. Or I thought that our problem it would still work. So wait, is it is that a 2? So I knew they were doing a different problem, but I was just looking at the technique. I didn't realize that that's what bio problem was supposed to be. Like, is that what it should be, bio? Otherwise, kth and n minus kth numbers are inverse of each other and there's no solution. Oh, yeah. I wouldn't have thought of myself, but when we say like that does like make sense. Okay. So I guess we'll do it with 2, just to show the answer. Write that a bit more clearly. All right. Combinations still cancel out. That cube root of 2 to the 6 becomes 2 squared. That cube root 3 becomes n minus 6 over 3 negative. N minus 6 over 3 times 3 to negative 2 equals 1 over 6. Okay. Hopefully we get n equals 9 out of this. If not, then I'm going to quit math forever. So this can come down to the bottom, and we can multiply the insides. 6 to the n minus 6 over 3, because they have the same exponent. That's going to be, actually, we're going to need to get that to be 6 squared. This problem. So 6 to the 2 minus n minus 6 over 3 is equal to 1, or we should write 1 over 6 as 6 to the negative 1. So we can just equate the exponents and drop the 6's entirely here. So 2 minus n minus 6 over 3 equals negative 1. Now it's just a simple single variable algebra problem. N minus 6 over 3 is equal to positive 3. So you multiply each side by no. N doesn't equal 9 here. Did I do something wrong again? Three to the 8 minus 2 over 3n equals 1 over 6. Which should be n equals 9. I think I'm just doing something slightly wrong. Because it's now this does match the website that I was looking at. The problem is they stated it, and they got n equals 9. We just go to Wolfram. So it'll be easier than trying to spot the error. Quitting maths forever after this question, you don't need to degree. I'm right there with you, Elroot. This question is... I know what it's supposed to teach you. It's really... It's also just not an easy question. 2 squared multiplied by 3 to the minus n minus 6 over 3 over 2 to the n minus 6 over 3 n minus 6 over 3 times 3 to the negative 2 equals 1 over 6. Go. Yeah, n does not equal 15. Don't need that. Don't need that. I never even talked about that. The person who asked about was probably gone. Sorry to whoever asked that. I forgot. What do they do on the site? Why would we swap the numerator and denominator? 2 to the 1/3 n minus 6. Oh, I guess that's what they do here? The order P and Q Did I write something backwards? I thought this matched and just it was a x plus y. Oh. Oh wait, no, I did the second one. Is there? I don't see a difference between these. Except the order of terms. Well, how are we supposed to... Okay, I mean, yeah, you're probably right then. We do have to swap it. I don't get how we're supposed to know that, but I guess you're right. It's very, like... I guess Bio's probably just taught it in a particular way. So... Let's erase all this. Get this stupid crap off my whiteboard. Oh my god. Raging at math. What a nerd. Okay, so if that's n minus k and that's k equals 6, n minus 6, just 6, k equals n minus 6, that's n minus 6. And that's n minus 6. Okay, try it with this. I'm not even going to bother writing the combinations. I'm getting lazy. That's not obvious. 2 to the n minus 6. 1 over root 3 to the 6 over. Six. No. All right, try it like this. 2 to the n minus 6 over 3 times 3 to the minus 2 over 2 to the 2 times 3 to the minus n minus 6 over 3 equals 1 over 6. Okay. Now on top, we get 6 to the n minus 6 over 3. On the bottom, we get 6 squared equals 1 over 6. Subtract those two. 6 to the n minus 6 over 3 minus 2 equals 6 to the minus 1. The bases are the same, so let's equate the exponents and pray to the Lord that we're right. Oh, I think we're right. Add 2 to each side to get positive 1. N minus 6 equals 3. N equals 9. Fucking hell. There we go. Nice catch out, Elrud. You could not say you were right all along, Bio. You wrote the initial problem wrong. You were right about the order of the terms mattering, but I don't want to hear it when you wrote the problem wrong, okay? Oh my god. Hey, you cheap hair transplantation. Damn it. Alright, that's kind of funny. Only with a cheap hair transplant in Turkey, though. you pay for my plane ticket out, I guess. It's right all along. Okay, I don't think there's anyone else that I'm missing for like questions from chat. So someone does have a question. Oh wait, Elwood, like a million years ago, you did ask about that integral and Penn Center kind of got it. Is this you, Elwood? Yeah, it is. Integral 1 over 1 minus sine x. No need to write the whole thing out? Oh, okay. Okay, I just want in that case, I'll just like leave it. I worked this problem out and then I erased it. Which actually, I mean, that's a great problem to have. Like, it's been 3 hours and 20 minutes of just viewer questions, basically. You're actually a Russian agent whose mission is to prevent American math research. Oh, good. Let me say, you're targeting the wrong person here. I can barely handle apparently a high school level problem, so. Did a little number theory homework you had trouble with? Yeah, sure. Number theory isn't my specialty, but I can try it. See, did someone else already answer this? If not, I can try to Oh, it's saying to do it backwards, which is probably better. I want to show that if P is prime and P divides AB, P divides either A or B, but we have to do it with Bezout's lemma. Let's see what that is. Lemma. For all integers a and b, there exist integers s and t such that the greatest common denominator of a and b is equal to a linear combination of those two numbers. Really? I guess that makes sense. Bezout's lemma, yeah. Inclusive or? So P divides A and or B. If P is prime and P divides AB, or if P is prime, then P divides A and or B. How would we use? I'm just saying Bezout's lemma. P is prime, P divides AB. Really? How the heck? That's true? Oh wait, that might not be that crazy. Divides either A or B. GCD is the smallest, the linear combination A and B are precisely multiples of GCD of A and B. You just got that TAB over P has to be an integer, where T is just the lemma. Not sure if that helps. It's farther than I've gotten in my head so far. I've done very few like number theory proofs. I feel like I understand one if I read one, but I have a hard time thinking of them like this, or like I have a time like creating them for myself. So yeah, I guess we don't necessarily know that like P is the GCD of A and B, do we? Because yeah, it might not even divide B at all if it divides A. Hmm. I almost wonder if you want to do like GCD of like P comma A or something. Maybe, so I'm really not sure where we're gonna go with this, but just to explore some different like applications of it. Like just because the letters happen to match, I've been playing around with doing GCD of A comma B, but maybe we want to do it with P comma A or something like that. Let's just write like I guess all three combinations of them down and see if anything springs to mind. I'm gonna like T1 S1. Because I feel like, you know, we can say something about the greatest common divisor between a prime and a number that's not necessarily prime, right? Because like either the GCD is 1 or it's P. I don't know if that really helps, but That's kind of where my mind is going now. P divides AB implies that for prime ideals. The defining property of prime SPQ, maybe? If that's a defining property of prime element, yes, we do have to use Bezout's lemma. Sweet. If P divides AB, then P divides A or P divides B, I think. Is how you'd write that in logic. Okay. So yeah, I don't really have an idea past this, to be honest, now that I actually look at this. So I guess if there's ideas from chat, I'll take them. Otherwise, I'm going to be Googling. Wait. P divides AB, then P divides A or B. So they all are called, oh shoot. Come on. Put it in quotes. Oh wait, was I actually kind of on the right track if you do it as a proof by contradiction? Oh. So you assume that P does not divide A and P does not divide B, but P divides AB. So then you get both their GCDs as ones. That's what I was kind of missing. Like, you know, we could say it's either or, but I didn't know how you like choose one. Multiplying the left and right. It's a whole mess of Oh wow, okay, so I mean this seems like kind of an elegant proof to me. So you assume that P does not divide A and P does not divide B, but it does divide AB. So you take the GCD of PA and PB, they're both equal to 1. Then you apply Bezout's lemma to make linear combinations for each of those GCDs. Then you multiply that by that and 1 by 1, and you get this mess of things, but you can factor it all out, so it looks like a linear combination of P and AB equaling 1. And if the linear combination of them is equal to 1, that means the greatest common, that implies the greatest common divisor of them is 1, which is a contradiction, because that means they're relatively prime, if that's the right term. Eliminating number theory is always pretty elegant. Oh yeah, I'm sure. I've always had a hard time appreciating number theory, so I haven't studied it much. So I guess I'll drop the link in chat in case you want it. Elrid, you see it now? It's a nice proof. Yeah, it is. It I have the same. Oh wait, let's see, is there an improvement that we can make here? One easily turns your proof into one showing that if P does not divide A, then it divides B. If SP plus TA equals 1, then SBP... Whoa, whoa, whoa. Whoa, whoa, whoa. To do my Merriweather-Mark impression. This might be even cleaner. So you take A not or P not dividing A and show it must divide B. I'm trying to figure out where these symbols come from. I need to see both the proofs at once, I guess. SP plus TA equals 1. That matches that. Multiplying the other equation with B. Oh, so you just multiply this through by B. Probably. Which shows that you can make a linear combination of P and AB not equaling to 1? And that's at least part of the proof. You should, I guess, technically do it for P not dividing B, dividing A, and then P dividing AB to cover all your cases, I guess. I guess it's even simpler. It almost feels like cheating, but I guess it's not. P divides AB means left is a multiple of P, meaning B is a multiple of P. It's because AB is a multiple of P, which means that you have a P in each term. I get it. Oh, okay. So yeah, AB is some multiple of P because we're not doing a proof by contradiction or anything like that. So then B is equal to something involving like P times a number. Okay. Because yeah, we get to start with the fact that P divides AB, so okay. It's probably better not to use contradiction if you don't have to then. Okay, that's neat, I guess. What should I do now? I guess. It's been a fun stream for the day, but I guess we're starting to run out of questions, at least from chat. Just debating if I want to switch gears or I just want to like end things, I guess. Let me see. That boy, Randy, thanks for the follow. Yeah, I'm thinking I might wrap things up for the day. I don't see like a... Oops, sorry for the noise. I don't see like a friend stream on who I would normally raid. I do see there's Admiral Stapler playing chess in the math category. Let's see what's up with this. Let me... Maybe we should just go raid Admiral Stapler. Looks like he's doing something with chess, but might be fun to see what's up with them, because I do know that they do some math things too. So I think let's do that. Shoot, 1 second. / raid Admiral Stapler. Okay, so I'm gonna end the YouTube stream. If you're here on YouTube, I appreciate you. Be back on Tuesday with math.